All right. So Monday we talked about looking at a sub n sequences and actually writing the first 5 terms. Yesterday you were looking at a variety of different sequences and trying to figure out what they have in common, what they don't have in common. And we're going to look at more specific ones next week. That's going to be part of our idea. But today this week we're really just trying to kind of, how do I write things? How do I find my sequences? Those kinds of things. And what patterns am I noticing? So we're going to kind of look at that on these 7 problems today. And I'm going to try to give you some hints on how to write some of those rules, because that's going to be the new thing you're doing today. So our directions say, describe the pattern, write the next term, and write a rule for the nth term of the sequence. So when I do this, doesn't take too long to realize, hey, between 3, 5, 7, and 9, each time it's going up 2. So if I add 2 to 9, my next term is 11. So we got that first part done. And so I could write, I'm describing it as just my sequence is going up by 2 every time. But when I write the rule, the a sub n, I can't just write the 3 plus 2, right? It doesn't work that way. My n, if you remember correctly, was the term position. So I would have 1, 2, 3, we have 4 terms here. So I'd say in position 1, remember what that meant? The position 1 was a 3. In the second term would be 5. The third term was 7. The fourth term was 9. And when I write my sequence of a sub n here, I'm looking for what is my relationship between this term number and 3. Now, if I realize in my sequence that this is going up by 2, and it is consistent, and my term numbers are going up by 1, you're going to realize we discussed this earlier in the year, and we would call this a linear function because both things were consistent. And in a linear function, the 2 over 1 is actually your slope. So we're going to start multiplying our n by 2 and see what happens here. So I'm going to take 2 times my position 1, and 2 times 1 is 2. I would need to add 1 to get to 3. That would work. So then we're going to look at the next one and see if it works. If I do 2 times 2, I would get 4. If I add 1, I would get 5. And so I like to check a couple of them, make sure they work. So 2 times 3 is 6. If I add 1, I would get 7. So I know that this is the pattern that connects my a sub 1 to a sub n. So when I write my formula over here, what is my pattern? It's going to be 2, that was a constant. The thing that changed was my n, so 2 times n plus 1. So those would be my answers for this one. All right, so let's look at number 2. My sequence is 3, 8, 15, 24. And I'm going to notice here that this isn't quite the same. This one adds up by 5. And between 5 and 15, it goes by 7. And between 15 and 24, it goes by 9. So I can find my next rule because I know that I'm going to add 11 to 24, and my next answer is going to be 35. But then I need to find my a sub n. And at this point in time, I'm going to tell you there's more than one way to maybe write some of these. So whatever you're kind of seeing is what you're going to put down here. So I like to kind of look at my numbers in that T-chart. I don't know if a lot of people do, but for me, I'm a visual person. That helps out. So I'm going to put down my 1, 2, 3, 4. And then my numbers in those positions, and position 1 was 3, position 2 was 8, position 3 was 15, and then 24. And this time I realized that these numbers right here are not consistent. So this is not a linear function. That's what I know. But I do notice that, hey, if I look at this difference now, it's now all 2. So what that means is this is a quadratic function. So what I would do, or what I usually do when that happens, is I go right above here and I kind of write, well, hey, what if I square this first? So I kind of add another column and I write, okay, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. And then is there something I can multiply by between that squared to get to this, or is there something I could add is what I would look for. Is that possible? So right now I know, hey, I could add 2. Here I would add 4. Here I would add 6. Here I would add 8, right? So if I look at that, that would be, we said 2, we said 4, we said 6, we said 8, right? That's actually 2 times each one of these, right? So couldn't I rewrite, so would that work if I said, I'm going to take n and square it. So I'm going to square n. So I'm going to do 1 squared plus 2 times 1. So that would be 1 squared is 1 plus 2. That would give me 3. Let's see if that works. 2 squared plus 2 times 2. So that would be 4 plus 4. That gives me 8. 3 squared plus 2 times 3. That would be 9 plus 6. That would give me 15. So once you feel like you've got the pattern, now I need to go back up, and anywhere it's changing, that's where my variable is going to be. So the things that are varying. So I'm going to have n squared plus 2 times n would be my equation. Right? The other thing you might notice is, yeah, that's probably going to be the easiest one to notice. But if you found another pattern, you could totally use that. I know some people see that pattern as n times n plus 2. So that'd be like 1 times 3, 2 times 2. So that would be another way that you could write that one if you see that pattern. So don't worry if you see a pattern that's different than the one I'm doing. As long as it works on all of them, you're going to be fine. You just have to be able to prove that by testing those. So number 3 says 1, negative 2, 4, negative 8. So I'm going to notice a couple different things here on this one. The first one is, hey, this is being multiplied, right? I'm multiplying this by negative 2. Negative 2 times negative 2, I'm multiplying by negative 2. Again, I'm multiplying by negative 2, right? So my next problem, when I take negative 8 times negative 2, my next term is going to be 16. Okay? I need to find my a sub n. So if I look at this, and again, the box, this is totally up to you. You might not like writing it. I just like to put my term values. Term 2 is negative 2. Term 4 is term 3. Get ahead of myself. 3 was 4. And term 4 was negative 8. That kind of helps me keep my focus on, I'm connecting from a to a sub n. Like, I need to take this number. What am I doing to 1 to get to 1? What am I doing to 2 to get to negative 2? What I have noticed is that each one of these is times negative 2. So if you think back to our functions, we had functions that when we were multiplying by a ratio, the thing that changed it was that it was exponential and it had a base. So let's look at that and see what happens. If I was to take and try negative 2 to the n, that would give me negative 2 if n was 1, right? Sorry, I want to put a 1 in there. Let's try that. I want to put a 1 in here. That would give me negative 2. I need to make sure that gets to be 1. So if we think about that, when I'm working with my exponents, if this was 0, I would always get a 1, right? So let's try that. And so a lot of this is going to be a guess and check. You're going to try some things and see if it works. So the second one, so this would end up giving me 1. If I did -2 to 2 minus 1, I would get -2 to the first power, which would be -2. Well, that works. -2, and if I did 3 minus 1, I'd get -2 squared, which would mean I'd have a +4. So I think we found our pattern as we go through here. When I work this problem out, my pattern is going to end up being, my base was -2, that's what was being multiplied all the way throughout, to the n minus 1. I had to go 1 below the term number and I would come up with that answer. Okay. All right. Number 4. Let's look at this one. We have 2, 5, 10, and 17. And what I notice here is, hey, this is going to be +3, then 5, then 7, right? So the next thing I'm going to do is add 9, and my next term would be 26. Okay, remember earlier I told you if for some reason you have 3, 5, 7, 9, I know it's not linear because it's not consistent, but the second time I'd look at this difference, this would be a +2 all the way through. And if that's the case, I probably need to square my n term. So I'm going to create my box here, my terms, and then my positions in my sequence terms. So 1 would go with 2, the second term was 5, the third term was 10, the fourth term was 17, and I know I want to look at maybe squaring my n. So I would say, what if I squared the n first? Let's just do that. What if I did 1 squared? What would I need to do to get to 2? So I could multiply by 2. I could add 1. So I'm going to just start with adding and see what happens. So 1 squared plus 1 would give me 2. 2 squared is 4, plus 1 would give me 5. So far, so good. 3 squared plus 1 would be 9 plus 1 would give me 10. 4 squared plus 1 would be 16, would be 17, sorry. So we found our pattern here. I have to take my term number and square it and then add 1 to it. Right? You might have tried to multiply that by 2, but you would have found out that if I would have taken 2 times 1, I would have got 2. But when I did that the second time, I would have got 8 instead of 5, so I would have known that wasn't the right pattern, and I would have had to go find something else. All right? Okay, I'm going to erase this and pull up our next problems real quick. So a lot of this is going to be some check and guess on your part. Try to do your best without getting too frustrated. I know it can be very frustrating for people also when they're looking at it. All right, so in my second term, or number 5, we have 1, 3 over 2, 2, 5 over 2. So when I start looking at this, I'm like, oh, this is up 1/2. 1.5 to 2 is up 1/2, so I'm adding 1/2. 2 to 2.5 is up 1.5. So if I add another 1/2 here, I'm going to get my answer of 3. My next term is going to be 3. I also realized at this point in time, these are all the same things, right? So when I start looking at my term numbers, I have 4 terms. So 1, 2, 3, 4. And then my terms are 1, 3 over 2, 2, 5 over 2. We know we're going up by 1/2, so we're going to start by multiplying that 1/2 times my term value. So I'm going to do 1/2 times 1, which would be 1/2, And I would need to add a half to that to get that to equal 1. So then I'm going to try the second one and see if it works. So if I take a half of 2, right? Half of 2 is 1. If I add 1/2, I would get 1.5, or I would get 3/2, which is 1/2, which is what we wanted to get right here. When I put a 2 in, I get 3/2 out. When I do 1/2, I'm going to put term 3 in there, which would be 3.5, which would be 1/1.5. I can add a half to it, and I would get 2. So it looks like I found my pattern here. So when I go back and write my pattern, my a sub n would equal 1/2. The thing that was changing was my n right there, so I'm going to put a 1/2 in there, plus 1/2. Okay, so we had to do one with fractions. Let's do one with decimals. So we're going to do the same exact thing though here. I'm going to look at between 9 and 16.5, or 16.8, and that goes up 7.8. And between 16.8 and 24.6, I cannot talk, is 7.8. And then 24.6 and 32.4 grows by 7.8. So if I add that to my last one, my answer here would end up being 40.2. That's going to be my next term. Okay, what we need to do is find our patterns. I really like the ones where it's 7 point, like the pattern's consistent, because I know I'm usually writing a linear function. So when I go in and plug these in, I can say, and so I'm going to do this one a little bit different. I'm just going to do the showing part. What if I did a sub n, a sub 1, and I said, okay, I'm going to do 7.8 times 1. What would I have to add to get to 9? And that would be 1.2. And then I did a sub 2, so I'm going to put 2 in there. Does this work? This first one gave me 9, so 7.8 times 2, right? That would be 15.6. If I add 1.2 to that, I would get 16.8. And then I would try that for a sub 3. 7.8 times 3 plus 1.2. Does that give me 24.6? And it sure does. So I have my pattern here. So now I can go ahead and write my generic sequence. So I'd have 7.8. That was constant in all of them. The thing that varies is going to be my variable, so that's going to be my n. And then I'd have the 1.8. So I was multiplying every term number by 7.8, and then I was adding the same thing of 1.2 to that. Okay, so the last thing we're going to do is when I have patterns such as the chairs over here, I'm going to label, hey, this is term 1, term 2, term 3, and we're going to actually put it in terms of numbers then. So I'm going to let my n, I have 3 things to look at, and we're going to look for what is the term number out of it. So in the first picture, I had 6 chairs around that table. In the second one, I had 4, 8, 10 chairs. In the third table, I have 4, 8, 12, 14 chairs. So they want us to find out what would the next term be. So if I was a 4, what would you think my next answer should be? And we would notice here, say, hey, this goes up by 4 each time. So this answer would be 18, right? And so now I need to figure out, what did I do to 1 to get to 6? Again, this is linear. These are the same. So I'm going to start by trying to multiply through by this number. So I would take a sub 1, and I would do 4 times 1, which is going to give me 4. So what do I have to do to 4 to get to 6? I would need to add 2. and that would give me 6. And then we cross our fingers and hope it works for the next one. So I would have 4 times 2 plus 2. Does that give me 10? Which 4 times 2 is 8, plus 2 would be 10. But works on the third one. 4 times 3 is 12, plus 2 gives me 14. So I found my pattern. So my sequence that I would write would be A sub n. I would do 4 times whatever the term number is, so 4 times n plus 2. Again, there might be more than one sequence, but those are some of the easier ways to find them, looking for what is consistent. Good luck today on your problems. Sometimes you have to walk away and then come back to it, and you'll find some of those. But just do your best on it, and we'll talk more tomorrow on it. Thank you.